How many electrons, protons and neutrons are there in 6 grams of 6-carbon-12? So first of all, we will use the mole concept to get the value of the number of atoms. So 12 grams will be equivalent to Avogadro number, that is 6.023 10 to the power 23. So 12 grams will be equal to 6.023 into 10 to the power 23. Then this number is divided by, that is for 1 gram, we divided by 12 and then we multiply by 6 to get the number of atoms in 6 grams of carbon-12. Now, how many electrons are present? So, then we will calculate it like this. That is 6 grams of carbon-12 contains 6 into 10 to the power 23 over 2, and each atom of 6C12 contains electrons, protons and neutrons. That is 6, 6 and 6. So, number of electrons, protons and neutrons in 6 grams will be 18 multiplied by 10 to the power 3 in all the 3 cases. So, that will be the number of electrons, protons and neutrons. And now we come towards the classification of nucleus. There are different types of nuclei, like one of them are called the isotopes, other are called the isobars, then next one is called the isotone, then comes the isodiaphers, and then comes the nuclear isomers. Regarding isotopes, you can remember that isotopes are those substances in which atomic number and mass number are same. Atomic number are same, but mass numbers differ. So, isotopes, those set of nuclei containing same number of protons but different numbers of neutrons. Example, 6C12 and 6C14. So, carbon-12, carbon-14, where 6C14 is an isotope of 6C12. 6C12 is stable, whereas 6C14 is unstable. So, now we come towards, that is 1H1, 1H2, 1H3. We find that all of them have same atomic numbers but different mass numbers. The same is the case with uranium. The same is the case with the neon. And next one is isobars. So regarding isobars, you can remember that isobars are those substances in which atomic numbers differ and mass number remains the same. So those set of nuclei containing same mass number but different atomic numbers are known as isobars. Now examples will be 6C14 and 7 and 14. So carbon and nitrogen both found to be 14 mass number, atomic number 6 and 7. However, 6C7 is an isotope of carbon, whereas 7 and 14 is stable nitrogen. Then we come towards the isotones. Next one is isotones. So what are isotones? Isotones are those substances in which A minus Z number is same or the number of neutrons are same. That is called isotone. So those set of nuclei containing same numbers of neutrons are known as isotones. Well, then examples will be 6C14 and 8O16. So we are finding here that is from 14, if we subtract 6, it will be 8. And in 16, subtracting 8 will be 8. So carbon and oxygen group with the given numbers are supposed to be the isotones. Now there are certain mirror nuclei, that is nuclei with same mass number, but with the proton and neutron numbers interchanged, then the number of protons in one is equal to the number of neutrons in the other, and they are called the mirror nuclei. That is, they are the images of each other. After that, we can have some other examples as they are shown for beryllium-7. However, beryllium is beryllium-9, but here it is one of the isotopes we have taken, and other is 3-lithium-7, that is a stable lithium. Now, before starting with the radius of atom, you will further remember and increase to your knowledge, that is, there are isodiaphers and nuclear isomers. The isodiaphers are those substances in which A minus 2Z number is same. A means P plus N number, and 2Z number means 2P number, that is N minus P number. So isodiaphers are those substances in which A minus 2Z are same, and nuclear isomers are those substances in which atomic number and mass number are same, but their radioactive behavior is different, and the isomer are produced by the transmutation process or the nuclear reaction process. Nuclear transmutation is a phenomenon in which a stable nucleus is disintegrated by high energy alpha particles or neutrons. So in that context, there will be formation of another nucleus. The mechanism is called transmutation. Now we come to what is the radius. The atom is supposed to be sphere and nucleus also supposed to be sphere, and the order of the size of atom is about 10 to the power minus 10 meters, whereas for nucleus it is 10 to the power minus 15 meters. So we have to find the ratio of the atoms. So it is 10 to the power minus 10 divided by 10 to the power minus 15, and it comes to be 10 to the power 5. Then we come towards the volume, where volume will be 4 over 3 pi r cube, whether it is atom or nucleus, and the order of the radius of atom will be 10 to the power minus 30, whereas volume of the nucleus is 10 to the power minus 45, and if we simplify the number, we get 10 to the power 15. And next is about the density of nucleus. Well, the density of nucleus, well, we can take the nucleus of helium, beryllium, carbon, nitrogen, whatsoever the nucleus may be, but the nuclear matter does not change. That is, composition does not change. However, the number of protons and neutrons will change, but the composition of nucleus won't change. All the nuclei are made up of protons and neutrons, exception to hydrogen nucleus. So density of nucleus will remain always constant, and the order of the nuclear density is found to be 10 to the power 17 kilograms per meter cube for almost all nuclei. Another important thing we can go through with, like there is an example, like suppose that we have two buckets filled with water, and one bucket is filled with say 10 kilograms of water, whereas the other bucket is filled with 20 kilograms of water. No doubt that the amounts are different, but both the buckets contain water, so the density of water remains constant whether the amount is more or the volume is more. So main thing or main criteria which explains about the nuclear density, that is the material or the composition of that substance. So density of water will remain always constant whether its amount is more or less, whether its volume is more or less. Similarly, the density of nucleus that will always remain constant whether it will contain more nucleons or less nucleons. The order of nuclear density is found to be 10 to the power 17 kilograms, that is 10 to the power 17 kilograms per meter cube. But if we make the actual calculation, it will become nearly 2.4 10 to the power 17 kilogram per meter cube. Now the formula for density, that is rho is equal to mass of the nucleus to the volume of the nucleus. So nuclear density is independent of its mass number. As I have explained earlier, that is density depends upon the composition, not the masses or the volumes. Now there are certain examples. The nuclear radius of oxygen is given to us. Find the density of the nuclear matter. So density is mass over volume. Volume is 4 over 3 pi r cube, and r can be taken as r naught a to the power 1 by 3. So the solution will be like this. That is density is mass by volume, and we will compute the numbers. Like mass means 16 atomic mass unit. So 16 into 1.66 10 to the power minus 27, and that will be kilograms, and 4 over 3 pi r cube. So pi will be 3.14 and r cube will be, that is r cube we have to take. So we will compute the value of radius and we will cube it and we will get our answer. Neutron is electrically neutral particle and not deflected by electric or magnetic field. Neutron do not ionize the gases. Angular momentum of electron. Angular momentum. So we can explain angular momentum on the basis of classical mechanics and the quantum mechanics. According to the classical mechanics, the angular momentum is generally calculated by mr square. That is, angular momentum is I omega, where I is mr square and omega is v over r, so r will cancel off, and angular momentum is found to be mvr. That is according to classical mechanics. But according to quantum mechanics, all results are generally expressed in terms of the Planck's constant, that is h, and h is found to be 6.610 to the power minus 34 joules per second. And the dimensions of Planck's constant will be the same as that of angular momentum. So angular momentum of electron is found to be nh over 2 pi, where n is 1, 2, 3, and so on. N stands for principal quantum number. It decides the shape and size of the orbit. When neutron strikes with the atom, it penetrates into the atom. This important property of neutron is used for nuclear fission or sometimes the nuclear disintegration. Nuclear fission is a special nuclear disintegration that is carried out from heavy nucleus of 92 uranium-235 bombarded with slow neutrons. We will discuss it in the concept of fission. Neutron was first discovered by Chadwick by disintegrating 4 beryllium-9 nucleus by alpha particles. So when alpha particle is bombarded to the beryllium nucleus, 4Be9 nucleus, we get the value as a 6 carbon 13, and carbon 13 is unstable. It decays into a neutron and converts to 6 carbon 12, which is found to be a stable nucleus. Proton was first discovered by Rutherford by disintegrating the nitrogen nucleus 7 and 14 by alpha particles. So when alpha particle strikes the nucleus of nitrogen, that transforms into 9F18, which converts into 1H1 with 8O17 along with the generation of energy. Both processes, the Chadwick's and Rutherford's processes, were known as the nuclear disintegration or nuclear transmutation. So these processes were responsible for the discovery of neutron and proton. Nuclear transmutation is a phenomenon in which one nucleus converts to another due to variation in the nucleon number of the parent nucleus.